Hello everyone. It's January the 15th. So yesterday we had an issue. Is it yesterday we have an issue? Yeah, we have an issue. I think it's the website crashes. Yes, the website crashed. The LeetCode website crashed because we submitted our stuff very close to the end of the contest, and because of that, we didn't know whether we actually did it. And while later I tried it again, and it worked. So the method worked. The hint worked. You have to build from small to large. But the way I build it is actually different from the way the official solution, or not an official solution, but the solution I saw last October, it was different. My solution was literally build the tree from the smallest possible value, right? And now basically you're just union find. You are at a smallest value node. You look around. You're only allowed to union with other nodes that are smaller than you, right? So you do this union for all the nodes that have the same smallest value, and after that you go through the union find to find the number of counts, because they are supposed, if they're connected, they will have the same parent, right? You just kind of to find for all these nodes how many of them have the same parent, and if have multiple have the same parent, then they can form a good path, and then we use combination as well. So that was the way that I figured on my own. Well, not on my own. I did check the hint. The solution I had last October was very different. It's also building from small to large, the value, but it's based on the edges, and basically it's a little bit more complicated to explain. So basically we have each time a new edge we want to consider, and before we consider this edge, the two nodes that's connected to the edge are not connected. Okay, so if we know the subtree of these two nodes, right, that's about to be connected, if we know the max value, right, the max value that exists in the subtree of these two nodes, and because they're the max value overall, because we sort the whole thing based on the value, then when they connect, the total number of this max value on one subtree and the total number on the other subtree, they can all connect to each other. So we just multiply the two. Overall, the implementation is much easier on the second method, but I'm actually quite proud that I figured out at least one of them just by looking at the hint. So definitely helped. It helped that I have done it before. All right, anyway, so that's enough of talk. Let's go to today's number 57. That one is old. As old as it can be. 57. You're given an array, non-overlap intervals. Oh, I hate intervals. It's not the most fun. But intervals are important in calendars and stuff. It's actually quite important. Actually, I don't remember. There's a very smart way to do intervals. Damn, I forgot. What was the way to do intervals? Like to decide how many like overlapping, right? I don't remember. I think it's in my... Hold on, now that I was thinking about it, but before we do this, let me see. Do I have my list? I have my favorite. Nah, this is a nightmare. I mean, I solved all the nightmare, but largest variance. Number of good paths. Yeah, that's the one. Partitions, no. Oh man, I don't remember. Which one? Ay, ay, ay. It's a very classic kind of who is on schedule for each smallest time interval. No, is it a merging of the intervals? What was the problem? Yeah, so we have a bunch of, okay, yeah, that's the one. We have a bunch of intervals, right? Each interval has an ID, has a unique ID, and then they might overlap, right? So we want to find, as they overlap, we want to break the intervals down to its smallest component, right? And then we want to find for each smallest time interval which ID it belongs to. Yes, that is the problem. That is the problem. It has a very smart way to solve. I used to know it and I don't remember that anymore. I think it's sorted based on the start. Okay, and every time you hit, yeah, I think it's something like every time you hit a start, you add the ID to it. And you hit another start, you add ID to it. And every time you hit a end, you pop the ID out. And you keep that set always there. And then, yeah, this might work. You sort it, right? So every time you are at the start, you push an ID in, and you add another start. It doesn't matter, right? You add another start, that means we have one interval out, so you can just see who's on it, right? And then you add another one, and then you hit another, every time you hit a start, or every time you hit an end, that's when you have to handle this. Huh. But is that to put everything together and then sort all the start and end together? Yeah, I think it's to sort all the start and end together. Yeah, we'll break it up, all the start and end together. So once it's a start, right, the first one we add it to it, and then the second one, if it's an end, that's just an end, all right? If it's an end, we will do the current and then pop it out. Something like that. I think that's the thing. All right, anyway, so let's go back to this. The start and the end of the ith interval. An interval is sorted in ascending order by start. You're also given the interval, new interval that represents the start and end of another interval. Insert this to this such that intervals is still sorted in ascending order by start, and intervals still does not have any overlapping intervals. Merging overlap intervals if necessary. Return intervals after insertion. This is a good question, right? 1, 3, 6, 9. I add 2, 5. So 2 will be overlapping, so it'll be 1, 5, 6, 9. This is a very basic kind of dealing. I've done problem that we have to insert new intervals every single time, and they're like n times. So it's already sorted, right? So it's actually make it easier. So all we need to do is binary search the start. Okay. So binary search the start will allow you to find where we should be, right? Where we should be. And once you know the position, we can do, because they can be the same. If they're the same, that's fine. So what we can do is we do bisect right, okay? And every time we check, right? We check. So if it's the start, if this one is the start, then we do the check on the end. On the end. Ooh, hold a second. On the end. I guess it's fine. On the end, we just keep moving down, right? We keep moving down. We keep moving down. So when the start is here, oh, we might have to insert the front. That is fine. That is fine. We can insert at the front. Yeah, if this is smaller than this. Wait, can the two be the same? Like, what if we have 1, 2? Is it allowed? Okay, that's a good question. I need to know. Let's say 1, 3. Oh, that's not allowed because that basically is overlapping. Yeah, it's no overlapping. So yeah, so basically, if the interval is at the front, then we check this end with this, right? If it's smaller than this, then it's by itself. If it's larger than this, then we need to check, holy crap, then we need to check this. Mamma mia. Then what do we need to check? There gotta be a better way. I don't like this. What if we just split to get it out? Because it's not overlapping, so it's fine. So we can get it out into 1, 3. Let's start 1, 3, 6, 9, and then we attach it with an indicator saying if it's a start or if it's an end. We can do like a tuple 1, 0, 3, 1, 6, 0, 9, 1. All right, and then we do 2. Okay. Now if we do 2, then anything we do, right, and then we'll put it somewhere, right? We'll put it somewhere. So if we put it somewhere, then depends, right, on whether it's, yeah, we put it somewhere, and we do this end. We also put it somewhere, right? We put it somewhere, we put it somewhere. Then we need to analyze. But the thing is, if you do it this way, then you have to rebuild the entire thing. I doubt you like to do that. So, probably not. So if it's a not, then, right, again, we put 2 at the front, and then 5, we need to do binary search again, based on these values, right? And then it will tell you a certain position to put this value in. Okay. Again, we will check to see if it's the same, right? If it's the same as the one in front. Oh, if it's 0, then perfect, that's in the front. Otherwise, we'll have a value. Then we check if it's the same. If it's the same, that means this all the way to here will overlap with that one. Then in that case, everything in the front will be popped. Holy crap. We need to pop everything. Like if I give interval, say 0 to 6, right? If I give 0 to 6, these need to be all popped. Man, oh man. I just create a new one, right? I have to create a new one. Yeah, I do this and then I add the remaining. All right, it's fine. All right, it's fine. And then it's the same procedure if it's in the middle, right? If it's anyway, if the end is somewhere in the middle, it's not the same. It's somewhere in the middle. If it's somewhere in the middle, then we need to compare to this. If it's smaller than this and bigger than this, then, oh, mama, help me. Lordy. If that's the case, then we end here, all right? Or basically end here, and the remaining is the same. If it's larger than this, it's in here. Yeah, if it's the same as this, or in between, then the result is the same. If it's in here, then everything will be replaced by this new thing. If it's not possible to be in there. Okay, so yeah, it's not too bad, but interval is always, it's not fun. It's basically one of the least fun things out there, along with what? Along with should I say string operations, like palindrome and stuff. Man, those stuff can get complicated as well. All right, let's do this. It's already sorted, so Jesus, come on. What the hell? All right, it's already sorted, but we do need from bisect import bisect left. So we need an index equals bisect left intervals and new interval, and the key equals to lambda, basically a tuple 0. Okay, so we get an index, right? Then we get the index. So now if it's 0, yeah, we do the remaining. If it's not 0, then we compare with the front. We can get the front, right? We can get the front, right? We can get the front by, because it's in between these. I say if it's the same, then the front will just be all those. If it's in between these two, right? If it's in between these two, then it depends if it's, and if it's inside, then it's still going to be I'm trying to make it as generic as possible. Maybe it's easier just to, go through everything and then. Oh, that's a thought. Why don't you put another interval at the front? Guaranteed to be in the front. Then everything will be the same. That is a good idea. We can add a, -1, -2, -1 at the front, right? We have a -1, -2, -2, -1 at the front. How about that? We add 1 at the front. So intervals equals -2, -1 plus intervals. Okay. So when that happens, right? When that happens, I might as well add another one. I mean, all I want to do with this is to make sure that it will always be in the right position in the start. Okay? And then, okay, let's see if this will make it easier. So now we get an index, right? Then we can say two situations, and if intervals index, right, because it's the same, I go to the next one. So index -1, 0 is equal to new interval 0. So this is the two are overlapping. So if that's the case, then then from this index -1 towards the end, it's going to be it might be changed, right? It might be changed. So I let's call it J. I call it I. Okay, let's call it I. So okay, so they're the same. Now we can do J equals bisect left intervals, new interval. Huh. Can do this. Wait, I actually don't know. Can we do this? Okay. A, let's say 2 key equals lambda tuple. Can we do this? Oh, I can. Ah. All right. Then I shall do 0. I shall do 1 key equals lambda tuple 0. Okay, so this is the second one, right? So now we have the J. And then we can do the same thing, right? If intervals J minus 1 and 0 is equal to new interval 1. So now we have a situation, right? We have the start is overlapping on I minus 1, and the end we're overlapping on J minus 1. Then what do we do? What do we do? What do we do is we can return, okay? Return, oh wow, intervals from 1 to I, right? Because it's I minus 1. Hold on, I minus 1. Because I minus 1 cannot use. So from 1 to I minus 1, right? From 1 to I minus 1. Okay, 1 to I minus 1 plus something. The left is gonna be new interval 0, which is the same, right? The right is gonna be intervals J minus 1, right? Because J minus 1 is 0 is equal to this, so we're overlapping. So we're overlapping to 1. And now we plus intervals J to the end. Because J minus 1, J to the end, yeah, so that's 1. Else, so if this is not equal to, okay, so J minus 1, so I have J. J minus 1, 0 is not equal to the current end. So the current end, it could be in between, or it could be here. Oh, actually, that's actually not true. So if this is smaller equal to, right, and if it's smaller equal to, and if it's ending here in between the two, right, smaller than intervals J minus 1, 1, right, if it's in between the two, then we use this. Perfect. Now if it's equal to, what if it's equal to this? Equal to this is the same, right? But if it's larger than this, right, then we need to change. So we can put this else it's not going to be small, it's going to be larger than. We're going to do this. Same thing, but this is not going to be intervals. This is going to be new intervals. So basically add a new interval here. And then j towards the end. Now it got me thinking this should be the same, right? If it's smaller equal to the new interval and it's smaller equal to intervals I minus 1, 1. So the new interval, if it's in here or in here, it's the same thing because I start always with hold a second. If this is in between, if the start is in between the two, then we always use the intervals I minus 1, 0, right? And even if we use in here, it's the same. So it should be intervals I minus 1, 0. So that is not true. We need to use intervals I minus 1, 0, right? Unless this one is larger, then in this case, this is still gonna be this, but here is gonna be new interval 1. Okay, so the start, yeah, because it's in between the two, right? It's in between the two, the new interval, the start. So when we merge, it's always gonna be the smaller one. Right, and the end, if it's in between, it's always gonna be the bigger one, unless it's outside. So now we can say else. Okay, else means the start is in between the two. Okay, in between the two, then we do the same thing. Okay, and we do the j, and then if so between, now this is going to change because I minus 1, because we're going to go all the way to I, because it's currently, it's in here, it's in between two intervals, okay? It's in between two intervals. And this is I minus 1, so we go all the way to I. And then we always start with new intervals, okay? We always start with a new interval 0, and this will be the same. And here we'll start with new interval. Okay, let's give this a shot. I said this is not fun. It's never fun. And we can actually try to test as exhausting as we can. But I have confidence in this. I wonder when I did this one last time. Good question. I have no clue. Must be a long time ago. Still a good question. This is a good question. Classic. Come on. Ooh, wait. You gotta be kidding me. Oh, what the hell is wrong? Oh yeah, we have this situation. What the hell is this? We add 4, 8. Yeesh. What is this? Ridiculous. Something is wrong. Okay, hold on. So we have the ending. It's the ending has some issues. We didn't merge this one. So the j, right? If the j is interval 1, j is smaller than this and is smaller than this. If it's smaller or equal to the previous one, then we say, in this case, we'll always use j minus 1, 1. Yeah. Because the n is in between. And will plus interval j. We add 4 to 8, right? So 4 is here. 4 is in this situation, okay? And 8 is here, so j is here. So j minus 1, 0, is smaller or equal to, so I is this one. No. I is here, so I minus 1. So we do this. So interval I minus 1 is 3, all the way to interval j minus 1 is this one, is this. Right? And plus j. Oh, wait, hold on. No, I add this one already. What the hell? Wow, repeat 8, 10. And by doing this, I already take j minus 1. Right? I already take j minus 1. Yeah, that's this 8. Wait, that's not this 8. That's not correct. Because if I take this, it shall be 10. Hold on, doesn't sound right. Let me think. Hold a sec. Let's see. Let's see what's j. 4. 1, 2, 3, 4. Yep. Wait, no. Wait, what? Wait, what? Intervals. New interval 1. 0, 1, 2, 3, 4. Oh my god. You know what went wrong? I have no clue why I said bisect left. Supposed to be bisect right. I was thinking about bisect right. There we go. Alright, let's add some fun. Let's have some fun here. So let's say if we do all possibilities, 0. Oh shoot. We can't do this here. You know what? Let's do it here. Yeah, this one we can do. Oh no, we all start with 1. Okay, we'll start with 2. Okay. So then we do 0 to 1. Right? If we do 0 to 1, then it shall return 0, 1, 2, 3. Right? That's what it should return. If we do 0, 2, that shall return 0, 3. Right? If we do 0, 4, that shall return 0, 4. Right? Okay, so that's on the 0 situation. Let's try this. Okay. We can also do. That's about all. Alright, let's submit this. What else can you do? All right, let's do one more. Let's do one more. Let's do, how about 3 to 6? Yeah, 3 to 6 is a good one. So it should be 2, 9, right? Should be 2 and 9. And how about we do 4, 7, all right? For 7, it shall be 2, 3, and 4, 9. How about we do 0, 10? The result should be 0, 10. Yep. Looks good to me. Try this. 2019. Oh my god. I'm so confident. And it got wrong in the first, such a simple test case. Jesus. How did this one not right? Oh. Lord. Missed the simplest one. What happened? I got 6. Oh, this is the situation we didn't consider. What was the limit? 10 to the 4th. Okay. 10 to the 4 plus 1. 10 to the 4 plus 2. And then, when we go to the end, don't go all the way to the end. The last one, don't take the last one. Interesting. I did not expect that to happen. Still not right, huh? Well, now when 6 comes in, it's not on the outside. Right? It's not on the outside. So when this comes in, it'll be 1, right? And it should be just this situation because it's out on the outside. And J comes in, will be also, it should be on the outside, right? I think this is wrong. Is I minus 1 here? This should be I. Ah, am I not even... Yeah, I don't think this is this problem. It's okay. It's okay. I was on the wrong thing. There we go. Yeah, I forgot. This one not supposed to be here. All right. Last time we did this was 2020, 2019, 2023. Want to take a look? Curious. Java. So easy. The hell? If interval 1 smaller than interval for interval, if intervals 1, okay, if, yeah, left and right. So I find all the intervals on the left. Who is bigger than me? Whose n is smaller than me? Fair enough. And then the new one. Oh, okay. And then we go on the right side, whose start is larger than me. So this one will be the start is smaller than me. Oh. And then what? If left plus right is not equal to intervals, what if left to right is intervals? If left plus right is intervals, then then there's no overlap. If it's this, then we say the net ns is gonna be intervals line left. We pick the smaller of the two, and then we pick the larger of the two. Line right, and we use this. Holy crap! It's so much easier than the analysis I was doing. Oh. For low and high in new interval. However, this is not the implementation, right? The implementation is quite complicated. On plus log n. This is on. This is log n. O is log n. This is on. Alright. So solution 2. Let's see if we can handle it. From 2020. Okay, so left equals for enter in intervals if enter 1 smaller than new 0. Okay, we'll do right. Interval enter if this is 0 is larger than intervals. Okay. If left is not if left plus right is not equal to intervals, we do have overlaps. Then I see. Start and equals new intervals. Oh, such a good solution. New s, new e. And new s shall equal to the minimum of new s and intervals len left 0. New e shall be the maximum of new e and intervals something. Well, what's this something? Well, I can say minus len right. Okay. Then minus 1. Then we'll return left plus ns and e plus right. Oh, so much better. Oh my god. Yeah, it's slightly slower, but it's okay. Just did hit 69 milliseconds though. Okay, so that's that. Oh yeah, we can use the binary search for those two positions and then do this. That's all right. I like this one. But I think, oh, I can do binary. Hold on. We might have a solution 3. What if I say I equals bisect right, okay, intervals, new s, key equals lambda, tuple, and tuple 1, because that's 1, right? So we find one that if it's equal, it will go to the next one. So that's the I, which means if the two are the same, right? If these two are not the same, then we have a left. All right, then we just say if and what if, just using the start, right? What if the start is smaller than everybody else? What if start is smaller than everybody else? Then we're gonna have I is just going to be going all the way towards I is gonna be 0, right? So it will be if I is larger than 0 and intervals I minus 1, a1 is equal to ns I minus equal 1. Right, we need to move it forward. Then j equals bisect right, intervals, and e, key equals lambda, tuple, we use tuple 0. Right, and then again, if j is larger than 0 and intervals j minus 1, 0, right, because j is here, and then we compare this to the end. If they're the same, right, equals ne, j or plus equal 1. So we don't need this. Right, then what we need to do, well, if there's no overlap, basically we want to find a situation where there's no overlap. If there is no overlap, what's going to happen? Then I will be oh, it's not, it's smaller equal to, right? It's what's smaller equal to, and this is, wait, no, hold on. So we go to the previous one. Wait. We comparing. No. This still has to be 0. We are trying to say, right? We go to this one, right? This is I minus 1. So if it's if this is larger or equal to, that means we have overlap. All right. Then we have overlap. We have this, and yep. Now we have overlap. If not, then we'll be here. And then in this one is the same. Then we say if this is the end, right? And compared to this. So if this is smaller equal to, right? Smaller equal to? No, because we search for this, that's still going to be 1. And the larger equal to this, then we have overlap. All right, because we look for the previous one, so this is definitely going to be equal or larger to this. So if it's this, if this is larger or equal to this, so the previous one is larger, then we have overlap. Otherwise, if the previous one, right, J is here. If the previous one is smaller than this. Okay, so if I is smaller than J, right? If this is larger or equal to, so we have overlap. Hold on. J is here, right? At the end is either here or here. So if we end is in here, because that's the J. I don't know who is like all larger than me. Yeah, the start. These start is larger than me, right? So if I'm here, I'm equal, I point into this. If I'm here, I'm also pointing into this. Right? And if I'm here, I'm also pointing. No, I don't think we need to handle J at all. No matter where the J is, J is always, because that's always going to be larger. Yeah, I don't think we even need to do J at all. Now we have overlap, so it's just going to be, yeah, J towards the end and towards I, these are no overlap. So I and J. No, if I plus 1 is not equal to J, that means we have overlap. All right, then when we have overlap, I is no overlap, so I plus 1 is the one we have overlap. So we do I plus 1 here. We know J is no overlap, so it shall be J minus 1. Let's see, I'm not sure. Left is not defined. Of course left is not defined. It should be intervals towards I, right, plus intervals towards J. Which one? I fail on all of them. Hold on, let me try it again. I will be binary search, okay, on the small, okay. And our binary search will give me the index. Then we say if I is 0, then we don't do anything. If I is larger than 0, because what we want to know from start to I, maybe we should do this. No, doesn't work. Yeah, we add this. If intervals I minus 1, 1, is larger or equal to this. Now then we say we have so we I to I minus 1. Hold on. I think this is I, because what we say, we want to make I, okay, let's just do I as the first overlapping position. If I is the first overlapping position, then it should be I equal to not equal to j, right? If I is the first overlapping position, then this is I is the first overlapping position. That's right. Overlapping position. So this is overlapping position. And j is definitely the overlapping position, or j is not the overlapping position. So this is I, so new interval I is the overlapping interval with ns. All right. J. That makes sense. Wow, took an hour. All right, that will be it. Yeah, we're gonna end this, but this one has been staying around for a while. You don't want to read it? Maybe we can read it, just don't solve it. What is it about? Some robots and factories on the x-axis. You're given an integer, a robot. A robot I is a position I. You're also given a 2D integer factories, where factory j is position limit. Indicates the position j is the position of the jth factory, and that j factory can repair at most limit j robots. The position of each robot are unique. Okay, position of each factory also unique. Robot can be in the same position as factory initially. All the robots are initially broken. They keep moving in one direction. Direction could be negative or positive. When a robot reaches a factory that did not reach its limit, the factory repairs the robot and it stops moving. At any moment, you can set the initial direction of moving for some robot. Your target is to minimize the total distance traveled by all the robots. Return the minimum total distance traveled by all the robots. Test cases are generated such that all the robots can be repaired. All robots move at the same speed. If two robots move in the same direction, they will never collide. If two robots move in opposite directions and they meet at some point, they do not collide, they cross each other. If a robot passes by that reaches the limit, it crosses as if it does not exist. If the robot moves from position x to y, the distance it moves is y minus x. So this one is already here, so I can fix immediately. This one is 2 plus 2 is 4. I see. This one is it's 2. Okay. I'll think about it during sleep today.